Good morning, guys. Today we're going to be looking at systems of equations, but in word problem form. And today's objective will be that we'll be able to write systems of equations involving 2 or 3 variables. So 2, coming from Algebra 1 and 3 from Algebra 2. And we're also going to be looking at a useful tool for solving systems of equations, and that tool is going to be matrices. We're going to be using the calculator. I'm going to be giving you the solutions, but we're going to practice inputting different values into the calculator in class. So since we don't have access to a calculator, I'm going to show you kind of the steps of how to break down what we're going to input, and I'll be showing you a couple of examples of how it's going to look like on the calculator. But for now, we're just going to take the answers as they're given, and then we're going to plug them into the calculator. And I'm going to show you where you're going to go to plug those in. Okay, so let's go down to the intro. So there's several different methods used to solve systems of equations. The last lesson we talked about was the method of elimination. Today we're going to write systems of equations from word problems and solve them using matrices. Okay, so that's my intro. Matrices, a matrix is a rectangular array of numbers enclosed in brackets. And so this array, you might have seen arrays in computer science, but basically an array is just a list of numbers. And if you notice, for example, this matrix here, this is called a 2 by 2. A 2 by 2 matrices, because it has 2 rows and 2 columns. Let's see, if I break these down, let's say rows run from left to right, so this is considered a row, and a column is vertical, up and down. So we have 2 rows, 2 columns. Then the one over here, the matrix over here, is a 3. We call it a 3 by 3 because it's made up of 3 rows and 3 columns. Okay, and again we have rows go from left to right, so there's 3 rows, and columns go up and down. Right, so remember, columns is remembering the Greek temples and cathedrals. They have these pillars, these columns, and those columns run vertical. So that's how it reminds me, columns are vertical, rows are horizontal. Okay. So how do we use these matrices to solve systems? Okay, so let's say I have a system of equations like these. I have these 2 equations with variables x and y. How would I go about solving it? So what we can do is we can kind of write this in a matrix equation. So in a matrix equation, you're basically writing a matrix for the numbers in front of the x's and the y's, and the numbers after the equals sign. And then your writing kind of a matrix for the two variables, x and y. But the main idea is make a matrix of the numbers in front of the x's and the y's. So for example, here I have -3 and 4. These two are my x's, so these are -3 and 4 go here. And then -4, 3 is for the y's. And equal to -5 and 9 are the two numbers after the equals. Let me zoom out a little bit so we can fit the screen. And it says to solve a set of matrices that's in this format, so you have like the numbers in front of the x's and the y's, then you have a matrix made up of one column with two entries. One entry is for the first variable, the next one's for the second, is equal to the numbers after the equal sign. So I have two numbers after the equals. To solve something like this, we multiply both sides by the A inverse. And A inverse times A is kind of like the opposite of A, so they're going to cancel each other. A inverse times A is 1. So x, the solution to x and y is going to come from multiplying the A inverse matrix times the B. And again, this is the main idea, this last step. This last step, just kind of box it here. It's kind of the main idea. This is what we're going to use to solve in the calculator. Okay, that's the main kind of formula, but that's what we want to kind of use. And so to use this formula, we need to know A and B. So I'm going to show you guys how that's going to look on the calculator, and then in class we can kind of practice. And so for now, you just copy what I'm doing in the notes, and then we'll see how we can plug it in and get practicing on it in class, right? Because most students only have access to a TI Inspire in class, and so you need the TI Inspire to kind of use some of these functions. So we're going to practice the calculation functions in class. So let's look at, the first two examples kind of give you an idea of what we want to do with the calculator. Okay. So it says for examples 1 and 2, solve each system of equations by using matrices in your calculator. Okay. So I have the following equation, and actually this is the same equation from the previous page. Okay. So basically what we're going to write here is just what would be our matrix A and what would be our matrix B. Right? So I'm going to try and color coordinate so we can see what we're doing, right? So I have -3, -4, 4, and 3. Okay, so that's where those numbers are coming from. And then let me pick different colors. That one and brown. Okay. And then we have -5. It's going to go here, -5 and 9. Okay, so I wanted to kind of color code so that we know where everything goes. Which one is my A matrix? The A matrix are all the numbers in front of the x's and the y's. the B matrix are all the numbers after the equal sign. Okay, so I'm going to add picture. I took a screenshot from my calculator and I'm going to import it. It's this one. Yeah. So yeah, let me just zoom it in there. And I'll talk about it and we'll see what it means, right? So here I have my A matrix. And so again, I'm going to show you in the calculator how you're going to do that, or how you're going to get to the matrix option. And all we're doing is we're going to type in the numbers that we see in this box. And this is my A matrix. And everything after is my B. And it's raised to the -1. Right, so I have my A matrix. You store it in A. Then you take the B matrix, which is -5 and 9. You store it in B. And it's just, after you press enter, it kind of stores it in those two letters, A and B. So that way when you type A to the power of -1 times B, it solves it for you. So here I have my X and my Y. So X equals 3, Y equals -1. So let me make this smaller. So my solution is X equals 3, comma Y equals -1. But I can write it as a point, so it's going to be 3, comma -1. It's my solution. All right. So let's look at example 2. Again, I'm going to color code, so let me make sure I have the correct colors. Oh, actually, this one has a little bit more colors. Okay, I forgot about that. So, again, I'm not going to color code. I'm just going to keep it the same because we have more numbers here. But the idea for the second one is now I have three letters, three variables, and 3 equations. So I have 3 columns and 3 equations. Right. If I rewrite the equation, or if I'm writing out the A matrix, I'm going to write out the numbers in front. Now, if there are no numbers in front of the x's or the y's or the z's, then we assume that there's a 1 in front, right? So I have 1, 1, 1. So for my A matrix, I'm going to write 1, 1, 1. You can also write the B matrix. I already know it's going to be 6, -4, 27. So everything after the equals, I have 6, -4, 27. So I'm just going to write that over here. Again, I wrote 1, 1, 1 because it's 1x, 1y, 1z. Right, so it's like I'm writing all my x's here, all my y's, all my z's. Actually, let me write it like this. X's, y's, and z's this way. Okay, if I look at my second equation, is there an x in my second equation? No, right? So I'm going to put 0, 2, 5. Because I have 0 x's on my second equation. I have a 2y, so I'm going to put 2. And then I have 5z. Then the last row, remember there's a 1 here in front of the z. So I have 2x, 5y, minus 1. So 2, 5, minus 1. Right, so this is my A matrix. All the numbers in front of the x's and the y's. So I have 1, 1, 1, 1x, 1y, 1z. Second equation, 0x, 2y, 5z. Third equation, 2x plus positive 5y minus 1z. And everything after the equals. So again, I took a screenshot and I got the following. Okay, so I got the following. So I just typed the A matrix, right? 1, 1, 1, 0, 2, 5, 2, 5, negative 1. That's my A matrix. Then I typed my B matrix, 6, negative 4, 27. And I did the same formulation that I did for example 1. I did A to the power of negative 1 times B. And they gave me my answers for x, y, and z. So x equals 5, y equals 3, z equals negative 2. That down here. Okay. And then, so my answer is x equals 5, y equals 3, z equals negative 2. And so if I write that as a coordinate, it's 5, 3, negative 2. All right. Now let's look at the word problems. We're going to be looking at word problems in these notes, in these set of lessons. Because we're now ready to write some systems of equations from problem situations. We will solve them using matrices. So these are the 4 steps, right? We're going to write the system of equations from the problem situation using the variables provided in the problem. We're going to practice that. We're going to identify the A and the B matrices for that specific problem or example that we're working on. We're going to find A inverse times B using the graphing calculator. And then we're going to write a sentence that identifies the solution and what it means in the context of the problem. Right, so let's look at this first example. Okay, so this is example 3. Write and solve each system of equation word problems. Show all your work. So let's look at example 3. It says, a customer at Stripes bought a breakfast taco and a 32-ounce fountain drink for $2.58. Another customer bought 5 breakfast tacos and 2 32-ounce fountain drinks for $10.53. What is T, the cost of a breakfast taco, and D, the cost of a 32-ounce fountain drink? Okay, so T for taco, D for drink, right? Write a system of equations that could be used to model this situation. Okay, so I have a couple sentences here talking about what they're buying and how much it's costing, right? So they bought one taco and one fountain drink, and it cost them this much. So I can write an equation like one taco plus one drink came out to or equal to $2.58. Then I have another equation here. It says another customer bought 5 breakfast tacos and 2 fountain drinks for $10.53. So that's 5 tacos plus 2 drinks equals $10.53. So here I have my 2 equations based on what I bought, what the customers bought, and the price of those items. So then we look at part B. Part B is telling us to identify my A matrix and my B matrix. So for my A matrix, in the calculator, we're going to set up an A matrix. And so it's going to be made up of the numbers in front of the letters. So I have 1, 1, 5, 2. And this is going to be my A matrix. And then I have my B matrix are the numbers after the equal sign. So it's 258 and 1053. It's going to be my A and my B matrix. Right, so this is what I have so far. I have the equations, I have the matrices, and then letter C is asking, write a sentence after you get a solution. So I take a screenshot again. Of what I typed in the calculator. And so what I typed was my A matrix and my B matrix. So I just typed this matrix as my A, typed the other one as my B, did A to the power negative 1 times B, and it gave me the two values. The first one is the value for T, and the second one is the value of D. Remember, T was the taco. So this is the price of the taco. So it's $1.79. And this one is the price of the drink. 79 cents. Okay. It says asking me to write a sentence. Write a sentence that states the cost of a breakfast taco from Stripes. So we're just going to say a breakfast taco from Stripes costs $1.79. And then part D is asking, write a sentence that states the cost of a 32-ounce drink from Stripes. So we have that the 32-ounce drink costs 79 cents. So we're going to state that down here. A 32-ounce fountain drink from Stripes costs 79 cents. Right, so that's one equation there. Then we're going to go zoom out. So this is example 3. Let's go over to example 4. All right, in this example it says Marco is draining his 2 aquariums. The tanks are the same size. One tank has 7 inches of water in it and is being drained at a rate of 1 inch per minute. The other tank has 5 inches of water in it and is being drained at a rate of half an inch per minute. After how many minutes, M, will the tanks contain the same amount of water? What will be the height, H, of the water at that time? So we have 2 variables, the number of minutes, M, and the height of the water at that time. And so it's asking us to set up 2 equations. So set up 2 equations. Okay, so one thing we can say is that, for example, okay, so we have one tank has 7 inches of water in it and is being drained at a rate of 1 inch per minute. So the height of one tank is 7 inches, but is being drained. So drained means you're subtracting a certain amount. So you're subtracting 1 inch per minute. Okay. And then I want to move all the letters to one side, right? So I'm going to add 1 M to both sides plus 1 M, and that's going to give me H plus M equals 7. These cancel. So I have one equation, right? H plus M equals 7. Then we're going to look at the other tank. It has 5 inches of water and it's being drained. Again, drain means subtracted at a rate of 5 inches per minute. So we have the height of the second tank is equal to 5 inches minus the fact that it's being drained 0.5 inches per minute. So I'm going to add 0.5 M, 0.5 M, cancel here, and over here I'm going to have H plus 0.5 M equals 5. All right. So my 2 equations are going to be H plus M equals 7 and H plus 0.5 M equals 5. These are my 2 equations. And then for part B, it's asking to write my A matrix and my B matrix. So for my A, it's a 2 by 2. And remember up here, the H and the M, there's no numbers in front. So assume that there's a 1H, 1M, 1H, and 0.5 M. That's going to be my A matrix. And then my B matrix is going to be made up of the numbers after the equals. So 7 and 5. This is my B matrix. I have A, B. Right? H plus M and H plus 0.5 M. Okay. And so in the calculator we would solve, right? We would do A times to the power of negative 1 times B. And I went ahead and did it already, but I'll show you guys in class what we do again in that case. But the first question is, write a sentence that states the number of minutes it will take for both tanks to contain the same amount of water. So the answers that I get from the matrix, or from the calculator, is that I get that H is equal to 3 inches and M is equal to 4 minutes. So it wants me to make a statement about the number of minutes. So I'm going to say it will take 4 minutes for both tanks to contain the same amount of water. Okay, so I'm kind of just writing the same sentence that's here, right? Because the question is, or the instructions say, write a sentence that states the number of minutes it will take for both tanks to contain the same amount of water. So it will take 4 minutes for both tanks to contain the same amount of water. Where did I get 4 minutes from? From the answers that I'm getting from the calculator, right? So for part D, we're going to make a sentence about the height of the water. Write a sentence that states the height of the water in the tank at the time in part C. Okay. So at 4 minutes, the height of the water in the tank will be 3 inches. Okay, so let's go to the last two examples, 5 and 6. Five says, souvenir hats, t-shirts, and jackets are sold at a music concert. If a customer buys 3 hats, 2 t-shirts, and 1 jacket, that costs $140. If a customer buys 2 hats, 2 shirts, and 2 jackets, that's going to cost $170. And if a customer buys 1 hat, 3 shirts, and 2 jackets, that will cost $180. How much does the hat, t-shirt, and jacket cost? And so they're using H for hat, T for shirt, and J for jacket. Okay, so taking these three customer scenarios, right? So if a customer buys 3 hats, 2 shirts, and 1 jacket, it's going to cost 140. So I already have an equation there. It's 3h plus 2t plus 1j equals 140. Okay, so let's do that with the second sentence. Is 140. A second sentence, if a customer buys 2 hats, 2 shirts, and 2 jackets, that's 170. So 2 hats plus 2 t-shirts plus 2 jackets, that's 170. And then the last equation is 1 hat, 3 shirts, 2 jackets is 180. 1 hat plus 3 t-shirts plus 2 jackets is 180. So these are my 3 equations, and I have 3 variables. So then we would make an A matrix and a B matrix. So my A matrix is going to be a 3 by 3. And so I'm just going to copy, the numbers in front of the letters, right? So my first row has 3 H's, 2 T's, 1 J. Then I have 2 hats, 2 t-shirts, 2 jackets, 1 hat, 3 shirts, 2 jackets. So this is my A matrix. And then my B matrix is composed of the 140, the 170, and the 180. Okay, so this one's a little bit different. We have 3 variables now. And for this one, I did do I think it's this one. Yep. Okay. Alright. So for this one, made the same matrix, called it A. This matrix is B. Did the A to the power -1 times B, and that gave me 15, 25, and 45. But remember we said hats, t-shirts, and jackets. So the 15 corresponds to hats. The 25 corresponds to t-shirts. And the 45 corresponds to jackets. Okay. So it says, write a sentence that states the cost of a hat. So a hat will cost $15. A t-shirt will cost $25, and jackets are going to cost $45. All right. One more example. Okay. So last example. Sophia compares 3 fruit and nut gift packs. How much is the cost per pound of the blackberries, the pecans, and the peaches? So we have 3 packs here: taster pack, family pack, favorites pack. And notice the variables, right? Blackberries are B, pecans are N for nuts, and P is peaches. So the only one that's kind of different is pecans, because we're already using the letter P for peaches. So we're just going to use N for pecans. Okay. So to set up this equation, if I look at the different taste packs, or nut and fruit packs, let's look at the green one, for example. If it says 1.5 pound each for these three nuts and fruits, then it's, each one's going to be multiplied by 1.5. So you're multiplying 1.5 pound each, and it's going to come out to or cost $22.50. So we're going to write something like 1.5 times the peaches, the price per pound of peaches, plus if you buy 1.5 pounds of pecans, but they're using N for nuts, plus 1.5 pounds for the blackberries, that's going to cost you or equal to $22.50. Okay, so that was just doing the taster pack. Now if we look at the favorites pack, it's 3 pounds for peaches and blackberries, and 1.5 pounds for pecans. So that's going to be 3 pounds for the peaches, plus 1.5 for the nuts, plus 3 for the blackberries is $39. And then the last equation is based on the family pack: 3 pounds of pecans, 3 pounds of blackberries, and 4 pounds of peaches. So it's going to be 4 pounds of peaches plus 3 pounds of the pecans and 3 pounds of the blackberries. It's going to add up to, or costing, $51. Okay. And then we would want to write the A matrix and the B matrix. So for the A matrix is 1.5, 1.5, 1.5, 3, 1.5, 3, and then 4, 3, 3. This is my A matrix. My B matrix is 2250, 39, and 51. Okay, so I have my A matrix and my B matrix. And what ended up happening was when I typed this in the calculator, it gave me the following amounts. It said P for the peaches, well, actually let me write it out as a formula. So for peaches, it gave me 6. For the pecans, for the nuts, it was 4. And for the blackberries, it was 5. And it says, write a sentence that states the cost of the blackberries. And so, cost of the pound of blackberries. So, let me put A. A pound of blackberries costs $6. Sorry. Cost $5. The next one, a pound of pecans costs $4, and a pound of peaches costs $6. Alright. And that's it. That brings me to the end of the notes. Again, we're going to practice using the matrices in class with the calculators, the TI Inspires actually. And so I'll see you then. Have a great rest of your day.